Yes, let us continue the p block elements. We have seen that two allotropes of phosphorus, one is white phosphorus and yellow phosphorus. Then next is black phosphorus. Okay, black phosphorus. So it consists of two types. One is alpha black phosphorus and beta black phosphorus. Okay, so this is obtained from red phosphorus. You heat it in a sealed tube at 803 Kelvin, you will get alpha black. If you take white phosphorus and heat up to 473 Kelvin under pressure, then you will get beta black phosphorus. Okay. Then next is phosphine. Compound of phosphine we will start. First is phosphine. Phosphine properties and preparation we will study. First, preparation. Take calcium phosphide and react it with water. You will get calcium hydroxide and pH 3. You can also use hydrochloric acid, that is acid. You will get CaCl2 plus phosphine. Then in lab you can take the white phosphorus and treat it with sodium hydroxide and water, 3H2, pH 3 plus sodium hydrogen phosphide. Then properties. It is a colorless gas with rotten fish smell. Okay. Highly poisonous. Then if it comes in contact with the oxidizing agents like HNO3 or Cl2 or Br2, it explodes. Okay. Then it is slightly soluble in water. When it reacts with water, it forms red phosphorus and hydrogen. Okay. Then next, reaction with copper sulfate. Copper sulfate plus pH 3 will give copper phosphide and sulfuric acid. Then reaction with mercury chloride with pH 3 will give Hg3P2 plus HCl. It's very weak base, and if it reacts with acid, it forms phosphonium compounds. These are phosphonium compounds. Then use is important as it can come in the objective type questions. It is used as Ohm's signal. Okay. How? You take calcium phosphide and calcium carbide in a container, and after piercing it, throw into the sea. Okay, So when it comes in contact with water, it reacts and it forms phosphine, and there is an explosion and the gases burn, and it serves as a signal. It serves as a signal. In this way you can use as a signal, and the name of the signal is Ohm's signal. Next is phosphorus trichloride and phosphorus pentachloride. So simple, it's for preparation. React it with X2, so Cl2, Cl you will take, X2 as Cl, so just react it in limited quantity, then you will get what? PCl3. If you take Cl2 in excess, then what you will get? PCl5. Okay. Then one more preparation is there for PCl3, that is reaction with P4 with SOCl2, thionyl chloride. It forms PCl3 plus SO2 plus S2Cl2. So this is the preparation of PCl3 and PCl5. Now next is, we study the properties of PCl3 and PCl5 under different columns, that is we will see the difference also and the properties simultaneously. So PCl3 is a colorless, oily liquid, whereas it is yellow powder. Now PCl3, when it comes in contact with water, it forms S3PO3 plus HCl, whereas PCl5 reacts with H2O and form POCl3 and HCl, and further POCl3 reacts with water and form S3PO4. Okay, so that is the only difference, that here you get S3PO4, here you will get S3PO3. Then reaction with organic compounds. Both the compounds, they react with organic compounds and form its acid. So let us see the reactions. PCl3 reacts with acetic acid and PaCl3 reacts with alcohol. Similarly, PCl5 reacts with acetic acid and PCl5 reacts with, so this will form its acetyl chloride. Here also it will form acetyl chloride. Okay, but the other product is different, S3PO3. Here it forms POCl3 and HCl. Then with C2H5OH it forms C2H5Cl. Here also it forms C2H5Cl plus S3PO3, whereas here it forms POCl3 and HCl. So this is the reaction of the PCl3 and PCl5 with organic compounds. Now let us know the other property. PCl5 reacts with finely divided metals like Ag. It reacts with PCl5 and form AgCl plus PCl3. Similarly, it can react with tin to form tin chloride and PCl3. Now the structure of these both things, phosphorus chloride, it has tetrahedral structure and sp3 hybridization. Not tetrahedral, it is slightly pyramidal in structure. And here this is having trigonal bipyramidal structure. You already studied in 11th also, bipyramid. So how will be the structure? There will be 3 equatorial bonds, Cl, Cl, Cl. These are the PCl is equatorial bond. Then one above and one below. These are what? Axial bond. And you know that axial bond is longer than equatorial bond here. Okay. Then next, how this PCl5 exists in solid state can be asked. It exists in solid state as ionic solid. So PCl4 plus and PCl6 minus. In this way it forms. This is having tetrahedral structure and this is having octahedral structure. So this is one question. Then also it can be asked that why the PCl3, when it comes in contact with moisture, that is water, it releases some fumes. So the reason is that it reacts and form HCl, and this HCl is seen as fumes. Okay. Now next, oxoacids of phosphorus, very important, the structures of these oxoacids of phosphorus. First is orthophosphoric acid, that is H3PO4. So whenever there is oxoacids, the compounds will have surely double bond O1. One oxygen will be attached by double bond with phosphorus, the central atom, and the other will be always, other bonds will be always directly with single bond, phosphorus with single bond, and the hydrogen may be attached to it. It may be attached to this oxygen, or hydrogen can be attached to the phosphorus also. So let us see this structure of this H3PO4. This is the central atom. So first you have to make one double bond O. Then how many oxygens are left? 3 oxygens are left. Okay, so you can make one oxygen atom with single bond here, and 3 hydrogen atoms is also there, so it will form OH bond. So this is the structure of H3PO4. Then here one thing is very important, that it can release H as H plus. So how many H plus it can release? 3 H plus can be released. That's why it is known as tribasic acid. So that's all for orthophosphoric acid. Then second comes orthophosphorus acid. Phosphorus acid. So what will be the formula? 1 oxygen less, PO3. So same, let us make a central atom P, and then 1 oxygen atom with double bond. Then how many oxygen? Only 2 is there now. Okay. So attach the hydrogen with this. So 2 hydrogen is also over. Only 1 hydrogen left. So that will be directly attached to the phosphorus. So how many hydrogen atoms can it release? H plus, 2H plus it can release, so it will be what? Dibasic acid. I hope you understood. Then let us go to the next. Next is third compound, oxoacid is H3PO2. 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 Let me see the name of the compound. Or it's okay, you can see from the book also. No? H3PO2. Yes, then next is pyrophosphorus acid we have done. Now pyrophosphoric acid. Pyrophosphoric acid. The formula is H4P2O7. So you have pyro compound means POP you first write. Then 2 oxygen here, 2 oxygen here means how many? 3 has gone, 4 oxygen is left. So 2 each phosphorus will take OO with along with it you put H also. So 4 hydrogen atoms. So this is the structure. So simple. Okay. Now how many hydrogen it can release? 4 hydrogen atoms. So it will be what? Tetrabasic acid. Okay. Then last is metaphosphoric acid. It's very simple. Metaphosphoric acid. Metaphosphoric acid. Its formula is HPO3N. Means it is in polymeric form. So you can write it as HPO3N. Okay, N. So, or you can call it as polymetaphosphoric acid. So how the structure is there? There is, in this way the phosphorus is linked with oxygen. Then if one phosphorus atom is O, the other will be OH, the other will again be phosphorus, and so on. So in this way the polymeric form is there, and you can put in bracket and then write it as N times. So it will be polymetaphosphoric acid. Okay. Then okay, this finishes the phosphorus. The whole thing is finished. Now the next topic will be oxygen family, that I will take in the next class. So okay then.